function of x, critical values, yeah, of f are gotten by setting f prime at x equals 0. So when you set f prime at x equals 0 and then you solve the resulting equation, whatever you get is a critical value of the function f. So, so that is it. So for instance, e.g., if I give you f of x to be 5 or maybe plus 2x then plus 3x squared, what are the critical values of f? So to do this, I compute the derivative of f and equate to 0. So this is true if and only if 2 plus 6x is equal to 0. Because I compute the derivative of this function, I simply get 2 plus 6x. So if this derivative is 0, it means this is 0, because this is simply the derivative. Okay, so now if you solve this, we get immediately that, so you get immediately that x is nothing but minus 2 divided by 6, which is minus 1 over 3. So the only critical value of this function is when x is equal to minus 1 over 3. All right. How can we now go from finding a critical value to knowing whether this critical value is a relative minimum of a point or relative maximum of that point? First, recall that relative minimum means if I say that a point C is a relative minimum point of f, this means that f of C is less than or equal to f of x for any x in a given neighborhood of t. So for any x such that 0 is smaller than x minus c less than the delta for some delta positive. So if x lies in this neighborhood of the point C, delta neighborhood of the point C, and this inequality is satisfied, we say that the point C is a relative minimum of the function f. Okay. In the same way, the point C is called a relative maximum if f of x is less than or equal to f at C for all x such that 0 is smaller than absolute value of x minus c, and this is smaller than delta for some delta bigger than 0. So any value c that verifies this inequality in this neighborhood of the point C is called a relative maximum of the point, of the function f rather. Now, let's go back to what we were learning. We're trying to learn or relearn what it means to how to compute a relative maximum and relative minimum of a given function. And I said the first thing to do is to find the critical values of that function. Immediately we find the critical values of the function, the next thing to do is this, to check whether the derivative of this function, we watch for the sign of the derivative of the function to the left of C. So let me call it, so we watch the sign of the derivative of f to the left of the point C. So check the sign of f prime of x to the left of C and to the right of still the same point C. If f prime changes sign from negative to positive, that is, let me put it in this box, from negative to positive, then the point C is a relative minimum point. Okay? If, on the other hand, f prime changes sign from positive to negative, I put it in this box, plus 2 minus, then the point C is a relative maximum point. So that is what we do.